All right, what's up guys? This is Josiah here. I'm with Dylan, our main machinist at FDF Freight Shop, and we're going to talk about the development of the machine shop and how Dylan evolved from a machinist into a designer and now basically runs the entire machining department of FDF Freight Shop.
So in this corner is going to be our CNC operating corner where we hired a new machinist, 7 years of experience, Dylan. He's been into racing. He actually met me 10 years ago at some car meet that I don't really remember, and it's super cool to meet up this way where two professionals have come together to do what we love to do, and that's build race car parts.
No, I'll get caught in the machine.
What are we gonna say?
What's going on, guys? Today we're gonna go over how we machine our Mega Mantis shock mount from a piece of stock to the finished product.
Dylan, give me a quick 1 minute or 2 minute brag about yourself, what makes you so cool, and then we'll go from there.
Okay, I don't know about cool, but machining has just been something that I've been passionate about since high school. Like I did co-op in high school. It was always something that was really interesting to me from probably like the biking days. And this is like, that's a whole another thing of people evolving from like one action sport to the next, like bikes, skateboards, all that kind of stuff, into cars. Looking at all the bike parts, like seeing like custom built frames and everything, all the fabrication done to it, I was like, this is all really cool. It's all very interesting to me. And I'll see like the hub and like, man, this looks so cool. And there's all these little intricate parts. Like I want to be able to make that stuff. Like I find that amazing to look at and be like, somebody made that themselves with the help of machines, obviously. So that's what kind of drove me to further pursue it. And then in high school, I was like, yeah, let's do some co-op. Let's get into the shop and see if it's as cool as it really seems to me, right? And I did 2 co-op positions at 2 different machine shops in Peterborough. And from there, I was like, yeah, let's do this. So
basically when I first put my Facebook ad up, your best friend who was in your wedding recently
Dawn,
sent you the screenshot of the ad or the link or whatever, however that worked.
Yeah.
And then essentially, I hadn't even bought a machine yet, but you had known of the shop, and I'm like, we outsource a bunch of machining. You thought you'd be a good fit, so we basically put a ridiculous amount of faith in each other, and we're like, you're gonna start like next week, but we don't have the machine yet.
Yeah, there's no machine shop, but you are going to be the machine.
Yeah, you're
right?
gonna be the machine shop.
Yeah.
I'm like, we have enough work to house probably 15 machines, and we're just going to buy them every 6 months until you make it. So we started with the VF2 SS, so explain to viewers what that machine's capable of, what it is.
Okay.
And yeah, we'll go from there.
Okay. The coolest thing, honestly, is that you went out and bought a brand new machine. You weren't like, hey, I found this one at an auction. It was a really good deal.
That'd be bad.
And then it shows up and you're like, we're investing.
It uses a floppy disk.
yeah, you go to plug it in, you're like, oh, there's no USB in this thing. I think that you've done it right. Just trusting that, I mean, it's just like a car. If you can have a car with a warranty, it's brand new. Nobody else has messed around with it before, and you know the history is not there, good or bad, and you're just starting off on it. It's fresh, which is exactly what the machine shop was. It's completely fresh. There was nothing. That corner, like the first day that I came here, that corner still had a bunch of like random stuff pushed into it, and we're like, okay, the machine's showing up. Let's clean this.
This is roughly where it's gonna go.
Yeah, we're like, let's clean it out. Like it's gonna go here, right? So, but yeah, the VF2 SS again. SS was something at the start. I was like, I don't know if we'll need it that much. Now with how much billet we do, it's a lifesaver.
What are the numbers?
So,
horsepower, RPM?
Yeah, horsepower, I believe it's a 30 horsepower motor. So the machine itself has 30 horsepower. SS means it's just faster for...
Super speed.
It's super speed, yeah. So faster feed, faster rapid, and higher RPM. So 12,000 RPM spindle, if we're gonna get into the numbers here, I think the maximum feed rate is something like 890 inches a minute, or it's fast, it's very quick.
It's almost faster than the rapid speed of the tool room mill is its feed speed of its machining.
Yeah.
Which a lot of people don't understand what those values mean, but visibly watching it machine at that speed, this is super speed.
Yeah, you're like, yeah, this is pretty crazy.
So if you're gonna buy a machine, buy the one that has SS on it, just like
Yeah,
the old Chevelle in the 60s.
Yeah, I mean, if you're serious about it, I think investing into, and it's like Haas is like a mid-tier, I guess, but as far as the job shop goes, like you got the big boy version of it, right? Like the upgraded version, and it's come in handy more times. It's paid for itself. Having that extra, the RPM in the spindle, it lets us make better looking parts. It makes better tolerances. It lets us do things that are going to set us apart from just the normal guy doing it in his garage kind of thing.
Yeah,
right?
and when you're buying a machine and you think this one's cheaper, after you've learned how to use it and 6 months later, you're gonna be like, wow, I wish we could go a lot faster. And that's kind of what we anticipated.
Yeah, so yeah, right off the bat, we're like, man, this is crazy. Like we're running the spindle, like being very conservative, right?
Yes,
like building up to it. And we're like, this is a lot of machine. And now it's like,
we need more machines.
Yeah, I could run. Yeah, there's a few instances where it's like, yeah, I could use a little more like RPM out of this and or stuff like that, right? So, but yeah, that was the machine that we bought. That was the first machine. We stuck it in the corner, just kind of figured it out from there. And I think within like 3 months, we're like, we need a lathe.
Yeah. So then we bought a ST15, which was an attempt to reduce the amount of turn parts that we were outsourcing.
Yeah.
The majority of those being like misalignment spacers that go in Heim joints and different
studs, stuff like that.
Yeah, a lot of, you don't realize how many turn parts you have until you know.
You can make them yourself.
How many cycles have we done on the ST15?
Yeah, we're over 38,000. The first year alone, I think we did break 20,000 parts. And that was with the machine being installed, the learning curve, because again, this goes back to having faith in each other, like both ways. Me coming here and being like, leaving a shop that was established. I had no real reason to leave other than like making car parts is the only thing cooler than just machining stuff, right?
Yeah.
So me taking a little bit of a leap there, and then you also being like, well, okay, you're going to be the guy to do this, right? Like it's, you're doing everything. And
Didn't
then
know that would be the thing, but then you just fulfilled the role, took it upon yourself, and then we're like, I can do this, no problem.
Yeah.
Then you started developing into like programming and even some design work. But let's talk about the last machine that we got recently, which is the ST20Y.
Yeah. So
Explain
again,
those numbers.
Okay. So 20 is the overall travel. That's on
20 inches?
Yes.
It's good size.
Yeah. Good size for sure. Y means it's a 3-axis. Technically it's a 4-axis, but it's a 3-axis machine. So typically on a lathe you have a Z, which is going to be your depth, and your X, which is going to be your diameter.
Yeah.
Y is now also moving up and down across the X-axis.
Opening up the door for basically any shape in the entire world.
Yeah.
Because the spindle also rotates.
Yes, so that's your 4th axis per se.
Along the Z axis.
Yeah.
Correct?
They call it a C-axis.
It's a C-axis, but it's the rotating around the Z.
Yes.
If the Z was a
That
shaft.
is, yes, that is correct.
Like
Yeah.
if you were looking at it from a computer standpoint, it would be on the Z, but rotating on the Z.
Yes, yeah, rotational at the Z.
So
yes.
yeah, the ST20Y has opened up the door for making the same parts that we were making, but significantly faster and more efficiently.
Yep, I mean the one part alone, the smooth adjuster, which is being incorporated into basically any new design we make as far as a control arm goes, between 5/8 and 3/4 threads for our rod ends. We're like, how can we get that in the arm? That's basically how you and Autoraj are designing now, right? Because it's so good. On-car adjustability it's what everyone wants, right? So those parts alone justify that machine. Even if it never even made a misalignment spacer, which the machine itself is more rigid, just being bigger, that casting, it's a better machine overall. So like drilling, anything it does is just a little bit nicer. You have to work less to dial in your speeds and feeds. It's got a bigger window of where it's happy working, right?
Yeah, you need to explain to people that the harmonics within a machine are kind of dictated by the size and the mass of the machine.
100%, yeah. So what we found with the SE, or what we do find with the 15, is that there's only so much you can really do. Like there's a limit where you should be able to turn faster, take a bigger depth of cut, but now you're running into vibration or harmonics because it's just not rigid enough. It's a smaller turret. The casting itself is smaller. The castings have a lot to do with the machines because that's going to absorb all the vibration that the cutting forces are applying, right?
Yeah.
So, and even just the chucks are the same. You could switch those chucks from one machine to the other. So it's not so much clamping force. It's not so much the size of the jaws or the chuck itself.
But what are some things that you could do to reduce those? Maybe a 6-jaw or a collet type chuck?
Collet type chuck would help for sure. Yeah. And I think it's just now we're finding like the ST15's perfect at running those spacers, and we have it so tuned in that we can leave it running lights out on even now in stainless. Like we can say, hey, make another 100 parts.
But you couldn't do that
parts.
from day one.
Not from day one. I mean, when the lathe showed up, and that's what I kind of went over that fact. I hadn't run, programmed, set up a CNC lathe all on my own before. I had run, like as an operator, ran a CNC lathe, but this would be the first time I'm setting all my tools up, ordering tools, basically specking the machine out to do what it needs to do. So that itself was a learning curve, and again, trusting each other to just be like, yeah, you got this, or you're competent enough to learn this in a manner that's quick enough that we're not just like dragging our feet through this and we're making payments on a machine. We're not doing what we need to do with it, right? So it's, again, with the 20, no live tooling experience, but now we're flying. Like it's.
So would you say you've learned, like, could you go to school and learn all of this, or do you literally just need to F around in order to find it?
I think it's both. School did teach quite a bit. As far as the CNC side goes, it's like a generational change, really, where when I was in school, now this is also, it's 10 years ago, right? It was like just changing over. So we had one teacher who was pretty current in CNC, but some of the old guys that had started like teaching the apprentices 20, 30 years ago, they weren't doing any CNC work, right? So everything was very like, this is how you're gonna use the manual, like the surface grinder, and your projects are all done on the mill and the lathe, the manual machines, right? CNC, you sat in a class and they're like, all right, this is how you're gonna write a basic program to turn a bushing. But it's not like, hey, this is like your chip load on a carbide insert with a carbide boring bar and you're cutting 4140 heat treat. This is where you need to start. And so a lot of that stuff, like getting in the shop, making a part, and dialing in the part to get what you want out of it, to make a nice part, to make a part in tolerance, that stuff is more what you just have to do. There's not like just you read it and you go to the machine and you just do and hit the green button, which that's like what everyone says, right? Oh, you just hit the green button and the parts just come out, right? Like we're just printing money at that point. But there's a lot of dialing in and there's a lot of knowledge and effing around and finding out to get to that point, right?
When you program the initial part and then you go and watch it with your finger over the feed hold button, you see and you notice like maybe the drill cycles, peck return or something could be faster or shorter. Like it's doing its peck, but maybe it's returning back to full height. And then you can go in, you can manipulate that, and you can drop the program down another 3 seconds just off that one
optimization, right?
So then you get into how creative you can become simply just machining parts. And I think there's a big difference between being a push button machinist versus being a programmer and now designer. So basically, now that you've effed around and found out and you had the background in school and you've got the experience in machining, now you find yourself in this unique position of designing parts as well. Like our handbrakes, our shift knobs, and the Corvette handbrake, and a few other things.
Off the top of my head.
Talk about how you're now a designer with me and your boy Autorush.
I mean, again, it's just another trust thing where it's like, hey, I want to try this out, and you're like, let's see what you can do, right? So getting more CAD CAM time was another big thing. That's a reason why I wanted to be here and kind of like throw myself right to the wolves, where I was getting a lot of experience. I was well-rounded before I came here, but jobs would always they would just be missing one aspect of it, because like somebody's been there for 30 years and like he's going to be the lead programmer or whatever, or he's going to have the 5-axis machine because he's the senior machinist, where I'm working my way up and I'm like, here I saw an opportunity to basically like jump ahead 5-10 years, where I'm like, I'm the one doing it. I'm the one responsible for setting the machine up, programming the machine, making sure the parts are good, like all of that, where it's just not something that you're going to be able to get at all together, all in one time at most other shops around here, at least, right? Maybe that changes, but so that's what was so intriguing to me, and really like testing myself, which is something that you would be very familiar with, like pushing the boundaries, not being comfortable with just what you're doing and going like, okay, I can do this, what more can I learn? Like, and that's what being passionate about this, and I think it's why we're at where we're at now. But that was basically leads into the design, where I'm like, okay, well, I can have a 3D model that you sent me, a step file. I can program it. I can do it on my tool paths. You can give me the file, and I can make the part. I want to start making my own parts for my own car, for friends as well, and being like, yeah, I can do that for you. And then from sketch to model to on the machine to finished part, I want to be able to do that myself. Goes back to looking at that hub and being like, I want to make that myself. Like, I think that's so cool. And that's where we're at now, where now I'm starting to get to the point where on basic designs, I can sketch it out.
Did you doubt yourself at all in the beginning, thinking that you would be capable of doing something like that?
Yeah, I think there's always doubt. You're like spending hours on something and you're like, I just can't figure this out right now, right? And then you break through, or you do it a couple times, and each time it gets a little easier and you remember more, and then you're like, yeah, this is it. What was scary at the start, or something that you doubted at the start, it's literally just, it's everyday life now. That's just, you learn it and you don't look back.
Yeah, it's intimidating at first, but then once you get yourself into it and find it interesting, it seems like you were just willing to be challenged and like run into a roadblock and then solve the problem.
Yeah.
So, yeah, I mean, how did you come up with some of the designs that you have? I know somewhat of it would be based on, for the Handbrake at least, it's stuff that you have experience in seeing all around the world, and you want to manipulate or change how we do ours. And then with the shift knob, you wanted it engraved and you wanted it a certain shape.
Yeah.
So what
we'll
made you
talk
go
about that.
towards that?
So, I mean, for the Handbrake, and both are pretty universal parts, right? Like, lots of people make them.
Yes.
It's something that can go in essentially any car, a handbrake and a shift knob, right? So it's saturated. So we have to, you don't want to rip somebody off. You don't want to make it look really close but a little bit different than the next person's design. So for, I would say, like a month and a half before, just like looking up handbrakes. Like, we know all the popular ones, and then trying to look at like maybe some of the smaller manufacturers outside of North America, because there's a lot of talented people outside of like every like country and region is kind of like, you got your main components, right? Looking outside to not just be like, oh, that guy makes a handbrake and I like that design, I'm gonna steal some of that, right? So taking into account, I mean, there's a lot of driver feedback here, obviously, because we race what we build, right? It's true. So I can go to you, I can go to Cam, and I can go to the people using our stuff and be like, what do you think? Like, we get good input, and then I can put my own design input and my own theory that I've learned through machining. What's going to be efficient and easy to machine? Because you can make something super complicated, but then it's going to take 3 times as long, and then it's got to cost more. And then at the end of the day, like, I'm going to be like, that's really cool. It took a lot of like machining and programming. But if somebody else isn't really into that, they just want a handbrake, right? So we got to make something simple, stylish, doesn't look the exact. Yeah, cost effective, doesn't look the same as everything else, which is very hard to do with a universal part. So that's where I just tried to take little design cues that I would personally like in something. The radius edge is something that we added in just to make it a little bit smoother on a hand rather than like a 45-degree chamfer. Just little things like that aren't super complicated, but will make the product just feel a little nicer, more premium, that kind of stuff, while not breaking the bank tooling-wise, setup-wise, stuff like that. The bearings were another kind of a challenge on the handbrake, where the ball bearing, like, that's our go-to. We don't want to mess around with Delrin bushings and you got a floppy side to side. You can see it like in car, the handbrake's just like jiggling around.
Over time, the bearings hold true, and the bushings
it feels nice. Holes. Yeah, you give it a yank and it's solid, right?
You're pulling on it, given, I don't know, 100 to 200 pounds, just constantly.
Yeah, well, especially, you're not thinking about how hard you're going to pull the handbrake.
Maybe that's a little heavy. Maybe if your bore size and caliper size is wrong, you might be pulling on it that hard. If you're bending your shafts in your master cylinder, then you have something sized wrong.
True. Yes, that is true. But yeah, like making sure that the bearing tolerances are tight, and that's one of the reasons that we could change the design. When it was outsourced, the tolerances were not repeatable, so we would go to assemble something and then it's not to our liking, right? Now, doing stuff in-house, we have the final say on it, if this is what we are happy with or not. And if we need to change it, we can do it. We can just go to the computer, go to the machine, and we can change that all. So it's having that control to make the best possible part as well.
Yeah, I don't think a lot of people know how or why I came up with the original design that we had for probably 7 years running.
Yep.
But it was because I had zero access to any machines whatsoever. I bought a manual mill from a college about 45 minutes away, and all I did was buy a Chinese boring head, and then I said, if I get this Handbrake water jet, I'll be able to capture the bearings with laser cut aluminum sheet metal. I'll be able to connect the Heim joint using that method if the side plates bolt on. And then I was kind of like promoting it as if you could color the side plates differently.
Yeah, accent plate, right?
That's what made it cool. But the center body was 5/8 water jet aluminum that I ground with a flap wheel smooth.
Smooth it out, yeah.
And then I would bore with a bore head manually so the bearings would press in.
Yeah.
And that's how I made handbrakes with no tools.
Yeah.
So I had every limitation possible and still did that. And then that design ran for a while until...
Yeah, we polished it up a little bit and then it was getting done fully on a CNC
And it was so
machine.
polarized. Some people loved it and wanted it. And even though we sold the new one, guys were like, no, I want the old one.
Yeah, and I mean, we can, if somebody really wants it, we can say we got the fixture plates, like we have the files, we can do it. But yeah, it's being able to offer, and you can't please them all, right? Every design you do, somebody's gonna be like, not a fan. Especially with a universal part, because it's as much personal opinion as it is function for a lot of people, where they could care less how it is. If it's going to lock the back brakes up, they don't care about the bearings or what it's made out of or that kind of stuff. They're just like, I want to.
My opinion, cool. I like the look of the new one, but I like the feel of the old one.
Because you got giant mitts.
Yeah, yeah, big mitts, bigger knob, bigger handle. That's what I prefer. So when you're pulling on it, it feels more like a grip size, kind of like a bike, a BMX bike bar or something. It, like the old one felt a little closer to that, but the new one still is thicker than most, and it still feels fine. Also in my Corvette, I just had it mounted a little further away than I would like. So we might have to do something custom, but
luckily we can just kind of do whatever we want here.
That's the thing. You could, now as the new third designer, I could be like, Dilly, it's got to be close.
That's all we got to do, right? Yeah, and it opens up cool projects too. Like when Nate came up and he's like, "Hey man,
what's a Nate handbrake?"
Yeah, he's like, "Let's do some signatures." And now it's like, I don't have to go to you and be like, "Hey, Nate really wants this," and you're like, "That sounds sick, but I'm super busy right now."
Imagine the other companies where they're like, I got to outsource this, I got to do that, we got to pre-order 50. But here it's like you can just design it.
Yeah, I'm like, okay, I can take that on, and it's good practice for me, right? Because now I can do it. I don't even have to be here to do it. I can do it at home too. The design aspect of it, right? So now it just lets us expand, do cool things. Like
what would be great is if we got a laser engraver and we could put like Donnie D spec on it, and then we could put like Nate on it. All of the customization would kind of just be like in that pocket of the handle.
Yes.
You would just put. See, we're coming up with new ideas right in the middle of a discussion. And I'm pretty sure they're pretty cheap too.
I think they're very affordable, and especially now that we have the 3D printer, like you watch the videos of people making fixtures for stuff, like for laser.
Yeah,
it's just printer. You're like, it's perfect. You don't even have to lay anything out anymore. You just make like a little jig of a 3D printed jig.
Holds it in the same spot.
Holds the handbrake in, and you're like, send us over a file. It's printed. So. Okay, well, that sounds like the next step.
That's how you would customize the handbrake, and you just charge an extra $30 to get whatever you want.
Yeah, send us over a DXF file, and we'll get it on the handbrake, right?
All right, laser engraver next on the buying list.
Sounds good.
Amazon, let's go.
But and then so we can go back to the shift knob, where again it's a universal part. It's something that it's been done time and time again, and you're limited. You can't make a whole bunch of different. It's got to be something round-ish with a thread on the bottom of it, right? So it's been done thousands of times before. So again, you're always taking inspiration from designs that kind of maybe you are more partial to. I know I wanted to do more than one design because it's just, there's so many different types to experiment with too, right? So The original one, the cylindrical one that we're making, it is taken from the one that you made for the 350. It's a very similar shape where it's just like you got your cylinder, tapers in at the bottom, did a couple fillets, radiuses, stuff like that, where when you're doing it on a manual machine, you don't get to do that repeatably at least, right? And then we get to use the live tooling on the ST22 to engrave it, which is all in one. We don't have to make a different fixture and hold them and engrave them or whatever. It can all be done on that one machine. We can part it off, then we can put the thread in it, and we can do whatever thread we want. So we can even just make the bodies as stock. And then once we get orders, if it's an M10, 1.5, 1.25, whatever,
Pop it in the end.
stick them in the mill, and then we can tap it to whatever size we need, right?
Yeah.
We can keep those on deck. The teardrop style, which is what I wanted to make, that's kind of like, that's what I wanted in the S2000. So I'm like, I'm gonna make this,
Teardrop, yeah.
and then if other people want it, that's cool.
Should we make like a 3/4 16 thread in all of them, and then just have 3/4 16 2 whatever just sitting on the shelf?
We're gonna have to do something, especially for like the German guys, where you don't have like a thread on like a BMW or Volkswagen, right?
It's like a set screw thing.
Yeah, so we make adapter for that, and then just thread it, and then yeah, we can have a common thread moving forward.
This
is
needs to
kind
be
of
a
like
fairly large thread.
it would, yeah.
Yeah, because
Yeah.
even the Corvette I think is just a set screw and a flat spot.
Yes, that's correct. So yeah, we will evolve and come up with those solutions, but this was just another project to just like basically try it out, get my feet wet, do some design, get it on the machine. The universe or the teardrop style one, I did like a bit of doming, so it's not just a ball, it like decreases the radius a little bit, and it's not completely flat at the top. So then again with the live tooling, you're technically doing like a 3D path because it is rising and falling in the Z as it like traces FDF out.
Yeah.
Again, it's just something if you see, you're like, oh, it's not just a
You can
flat
appreciate
face.
this extra
Yeah,
step.
there's a little more effort gone into it. So, and that's how you try and make a universal part, just a little bit different than the rest, right?
So going forward with all these extra rolls, we obviously are going to be getting more machines, but I think you're maxed out at trying to run 3.
Yeah.
So going forward, we need 2 things minimum: more space and more employees.
Yeah, yeah. I mean, the space is probably the biggest part because we literally don't have another spot for the machine right now.
Yeah.
And so, I mean, it's always going to be evolving, and I think we have some options within the building that we can look at. So, yeah, I think, like you said, we could have probably 6, 7 machines in here and be busy all the time, which is crazy. Like when I came here, I was like, I don't know, like, am I going to be here for 6 months and I make a bunch of stuff, and then we got a bunch of stuff on the shelf, and I'm like twiddling my thumbs. Now I'm like, every day I come in, I'm like, okay, I got 2 weeks of backlog on every machine.
Yeah.
They got to go, right? So, but yeah, looking forward, the space, another machine or 2 or 3, however many it may be, and yeah, looking to find the right person to complement where we need somebody, again, we can put 100% trust into, and they just come in and they knock it out of the park, right?
Yeah, I mean, everyone that works here, it's kind of like a passion project for everybody. It's like they take pride in making the parts, the welds, designing the things, simulating it the best.
Yeah.
Everyone takes pride in every single aspect.
Yeah.
So the guy that we need to look for is going to need to be someone that wants to do and learn exactly what you've done and learned.
Yeah. Yeah.
And kind of take it upon themselves to do that. So that's what's cool about it, but then that's what makes it so niche for us to find such high quality people.
It can be difficult for sure. But like you said, I think every single person, like when they finish their job, like you said, whether it's welding, whether it's machining, whether it's designing, they look at the product and they're like, would I be stoked if I got that? Like when I look at something, that's where I'm like looking at, even if it comes down to a spacer, if I'm looking at it, I'm like, if I got this, if I bought this, I was on the opposite end of this, would I be happy with this product? If it's a no, you're not just be like, that one will be fine. You're going back to the computer, you're going back to the machine, you're fixing what needs to be done, and then you're continuing on. And I think everyone does have that mindset here, which is important. I agree. So yeah, moving forward, I think finding the right people, it always falls into place. Like obviously we didn't expect that this was going to be the situation when you bought a VF2 and you're like, I'm going to do it myself because I don't want to outsource.
Realistically, we should have probably bought the lathe first, but it was 6 months after, so it was fine.
Yeah, everything has happened the way that it needs to, and I think moving forward, and I think it'll be very cool, and we've talked about this before, we're 2 and a bit years into this now. We look back at another 2 years and we're like, wow, isn't it crazy that we were doing like this stuff 2 years ago and now we're doing this? Where before we had nothing. And now we're 2 years in and we're like, this is crazy, like this is super cool. In another 2 years, the stuff that we're going to be doing.
In another 2 years, it's an exponential growth scenario.
Yeah, and I'm looking forward to that. It's exciting. It's very interesting and cool to be excited in your work and your job, because not everyone gets that chance, right? So to be able to like come here and be like, I'm excited to do this work. Like I enjoy working. It's not something that everyone gets, so you have to appreciate that for what it is too, right?
Well, I'm glad you saw me 10 years ago with my silly little S13.
Yeah,
it's that stuck to your mind.
Yeah.
That's an overview of Dylan and his role here at the shop, how he's become a machinist and a designer, and he's pushing the boundaries of what FTF Race Shop is capable of. Thanks so much, Dilly.
Thank you.
Thank you guys for watching. We'll see you guys in the next one.